Hey, welcome back to Math with Patrick and Quill. Today is December 28th, and we're solving problem 362 from the Daily Epsilon calendar. The answer today should be 28 because that's today's date. So we just need to somehow solve for x, and x is supposed to be 28 for today. So for starters, I see the difference of two cube roots. Our first cube root is the cube root of 36 plus x, and then our second cube root is the cube root of 36 minus x. And this is supposed to be equal to 2 today. So I guess the first thing that I'm noticing is that we just have two numbers here and here whose difference is 2. Like, for example, the answer could just look like 3 minus 1 or 4 minus 2, or I guess 2 minus 0 could be a potential answer. Maybe we could look in the negatives also, because cube roots can return negative values. Like, for example, the cube root of -8 is -2, because equivalently we could cube 2 and get -8. So maybe with this just kind of rudimentary guess and check search, I would need to look in the negatives for a little bit. So why not? Let's just see what happens. How about let's just try to see what would happen if I decided that we have like 0 minus -2 as our first option. And then maybe like 1 minus -1, 2 minus 0, 3 minus 1, and then 4 minus 2. Like maybe there's a way to solve this algebraically, like we could potentially like add this to the other side and cube it, but honestly, I just kind of like playing around with the numbers first and just seeing what happens. So, okay, if this is now 0, the cube root of 36 plus x, if this is 0 here, then that must mean that x is going to be equal to -36, because the only number that we could cube root to get 0 is 0 itself. We get maybe a little bit of an issue now that x is a negative number here, because if we cube root 36 minus -36, we're getting the cube root of positive 72, and this is going to be a positive number, not a negative number. So there's no way that we could get a -2 for our second cube root there. So I think the second option is going to give us the same kind of issue, where if I'm assuming that the first cube root here is the number 1, I would need to be cube rooting the number 1, and that would make x -35. And then we run into the same issue where we have a positive cube root on the right side. Okay, let's see what happens now when we have, these ones. Maybe I'd look at the right one first, because the cube root of 0 is really easy to just figure out. That would be 0 itself. So x potentially could be 36 here. And then we would get the cube root of 72 showing up again. Although this isn't the number 2. The cube root of 8 is 2, so this one is going to be a little bit bigger than the number 2. So that doesn't work, but we don't have those weird, negative and positive issues from before, so I feel like we're going in the right direction. Let's just keep on trying. I could expedite this and think, okay, why not let's cube both of these values and see if it could possibly line up with the radicands here. So I could potentially get a 27 and then a 1 maybe out of it. I guess this would look like 36 plus x equals 27, and then 36 minus x equals 1. We could potentially see if we have a solution here. On the left side, this would suggest that x is -9, and on the right side, it would suggest that x is 35. So nope, never mind, that doesn't work. We could try this one last time. I have some good hopes about this last one right here, where we could decide to cube 4 to get 64, and cube 2 to get 8, and then we can see if 36 plus x equals 64, and 36 minus x equals 8. So in the left equation, we could just subtract 36 from both sides, and this gives us x is equal to 28. And then over here, maybe let's subtract an 8, subtract an x. That shows me that x is the same thing as 36 minus 8, and we do get x is 28. So it just takes a little bit of guess and check, and we can confirm that 28 does work. Maybe give me a sec to explore to see if the algebra way gives us anything interesting. So I did find an algebra strategy that's actually kind of useful to share. We could start where we start and just rewrite the problem. Cube root of 36 plus x minus the cube root of 36 minus x equals 2. And then, like I said at the beginning, a useful strategy is to add one of the radical expressions to the other side and cube both sides. Although before I do, I don't really want to cube both sides right now when I have another radical expression that I am cubing. So instead, I am going to just do a little bit of a change of variable stuff or some substitution. I'll just say that a is equal to the cube root of 36 minus x. And that's just this term right here. So this number right here is actually the same a that I'm talking about. So hopefully when I'm done with this, I can either show that x is 28 or a is 2, and hopefully that should mean the same thing. So cubing both sides, the left side's easier. We just cancel the cube and the cube root. And then now knowing that this expression is the same thing as a, I could just do the binomial theorem on this. And I am going to write it in standard form with respect to a. So I'll get a cubed here plus, and then the binomial theorem says that we need these coefficients of 3 and 3 right here. And I will square the a and raise the 2 to the power of 1. I will raise a to the power of 1, and then 2 squared. And then finally, the last one will be 1 times, and then this 2 cubed, so that's 8. If you're wondering where all these numbers are coming from, Google the binomial theorem, and then maybe the exponents will make a bit more sense. But overall, our coefficients are 6, and then we have an a squared. This one will be 12, and we'll have a to the power of 1. And then finally, our constant term is 8 at the end. So we still have an equation in terms of two variables, but fortunately, I could actually get x by itself in this equation, and then sub out the x and sub in an a. So we can cube both sides of this equation. And then to isolate x, I guess I could add the x and subtract the a cubed. So x is the same thing as 36 minus a cubed. And then now we just have a cubic here, right? Because 36 plus, and then 36 minus a cubed, that subs out the x. And then now everything is just in terms of a. So fortunately, cubics are solvable. Maybe let's set it equal to 0. I could do that by adding an a cubed to both sides. Looks like my squared and linear term will stay the same. And then when I subtract, looks like 72 from 8, I'll get minus 64. And this is all going to be equal to 0. All of my coefficients are even, so I can divide both sides by 2. And now it looks like I have the simplest cubic I'm going to get out of this. We do have a little bit of, secret knowledge that a is actually 2 today. So I could think through what would I do if I didn't know a was 2? I could use the rational root theorem. This would say that potential rational roots are positive and negative 1, 2, 4, and then all the factors of 32 divided by all the factors of 1. And I'm just going to be a little bit lucky and guess that positive 2 is going to be a root of this. So I could use synthetic division to figure out what the factoring of this is. We're going to drop and then multiply and then add and then multiply and then add and then multiply. And then what do you know? Once we add, our remainder is 0. This shows me I can factor this cubic as a minus 2, because again, the root would go here and create the value of 0 for this factor. And then minus a squared plus 5a plus 16. Now, this quadratic just kind of looks like it's not going to have any real roots. The idea being is that this plus c value is just so big that if we graphed it, we would have some kind of quadratic that doesn't touch the x-axis here. The way to show that this is the case is that we could take this b value, divide it by 2, and then square it. And this is going to be this perfect value that would give us exactly 1 real root out of this quadratic. And then 25 over 4 is just around 6, and 16 again is way too big. So this quadratic is never going to give us the value 0. So the only 0 we're ever going to see out of the cubic is when a is equal to 2. And we can scroll back up and figure out what this means. That means that this term right here is 2, and we could then solve for x, show that x is 28, and then double check that it would work for this one. Why not? We have the time. Let's show how this works. So a is equal to 2, and let's backtrack a little bit to, actually, let's go right here, because this can show us that x is equal to 36 minus 2 cubed, which is 36 minus 8. So x is indeed equal to 28 today. And then we could use this value and plug it in over here. Like we already saw, this does give us 64. And then the cube root of 64 is 4. And then finally 4 minus 2 does equal 2. So this problem is totally solvable just straight up using algebra from the start. But I do kind of like having a little bit of number sense at the start, a little bit of guess and check, just to ground ourselves of what happens when we try different numbers. So here is where the video ends. X is 28. That's today's date, and we're all done. So thank you for watching, and I'll see you tomorrow. Bye.